Okay, we have the concept for binomial distribution. So again, we already look at the concept where we have the binomial experiment. So actually, binomial experiment or binomial distribution is coming from Bernoulli trial. Okay, so the properties for binomial experiment when we conduct, it must have your n, which is number of trials. Okay, and then the trials must have two outcomes. We can decide success and also failure. Okay. And then the probability of success, which is we denote as pi. So pi remain constant for each trial. Okay, that's mean the second trial is not affected by the first trial. Let's say if we have the fifth trial, okay, it's not affected with the previous trial. So the process are independent. So that's why we can multiply the probability. Okay, and again the probability remain constant for each trial. So we have the probability mass function. So for binomial, normally we call as probability mass function for any discrete random variable. Okay, PMF. So the probability mass function is given as NCX, pi to the power x, 1 minus pi to the power n minus x. Okay, the important thing that you have to remember, when we conduct a binomial experiment, your x values, your small x, should be starting from 0 up to fixed value, which is your n. Okay, because we have many discrete probability mass function, but starting with different x and ending with different values. Okay. Okay, but for binomial, starting from 0 up to n number of trial. So normally when we write a binomial distribution, so x is distributed, clear this one. So x is distributed as binomial. Your parameter is n and also pi. Okay. The properties that you have to remember, if you have your ex, expected value is n pi. Your variance x is n pi 1 minus pi. Okay. So that is your binomial distribution, the properties for mean and also your variance. If you want to find your standard deviation, again, square root the value for variance. Okay, so we already identify which one is binomial experiment and which one is not. Okay. Okay, before this, we only discuss about your stats table. Your n starting from n equals to 1, the last value of n is equals to 30. Okay, why? Because normally when you have your n is greater than 30, we will use a approximation. Okay, it can be either binomial change to Poisson or binomial change to normal distribution. Okay, and then one more thing, your pi given in here is from 0.01 up to 0.5. Okay, so now we are focused on how you want to compute your probabilities when pi is greater than 0.5. Okay, so if you refer to your module, okay, again, so you have your x is binomial and pi. So we define another random variable, which is y. So y, still you have the same n, but you have different. Let's say pi is your success. Now 1 minus pi is your failure. Okay, the probability of failure. Okay. Okay, if you want to find, you can refer to your list of formula. Okay, if you want to find probability x equals to r, so that's mean you have to change y equals to n minus r. Okay, and then if you want to find probability x less than r, and then y, okay, you just change different variables. So the inequality sign, so you have y greater than, so again n minus r. Okay, it follows if you have less than or equal, so the same, you must have the equality sign, so n minus r. Okay, so the same thing for less than or so this one is less than or for greater than. So again, if you have probability x greater than r, so we change probability y less than n minus r. Okay, so that is the way how you can compute your probabilities. Okay, now if we refer to task file 4.10, okay, so given is your x is binomial distribution, but with n equals to 17, pi is 0.7. Okay, Haris, can anyone post back the Google form? Okay, if you coming late, maybe you can fill in back the Google form for your attendance. Okay, ask one of your friend to post it again. Okay. Okay, then we have this one. X is distributed as binomial and equals to 17. Your pi is equals to 0.7. Okay. So when we refer to this one, pi equals to 0.7 is not in your stats table. So what you should do, okay, now you use different variable. Okay, you can use either y, z, w, or whatever. Okay, and then let's see lah, we use y. Okay, y, binomial, n is equals to 17. Now your pi, 1 minus pi, so 0.3. Okay, so we change the inequality. So again, you have x less than 4. So we change to y. Okay, follow this one, y greater than. So 17 minus 4. Okay, so probability y greater than 13. Okay, so in order for you to find y greater than 13, so again, if you have y greater than, so use the concept 1 minus. Okay, 1 minus probability y less than or equals to 13. Okay, so again, now in your stats table, you find your n is equals to 17. Your pi is 0.3. Okay, n is equals to 17. Your pi is 0.3. Okay, so you have 13. So the probability is equals to 1. Okay, so again, you have 0. Okay, because the value, the last value is 1. So that's why we got 0. Okay, so now try probability x greater than 9. Okay, probability x greater than 9. So the same thing. Okay, you change to y. So greater than, it should be less than 17 minus 9. Okay, so and then you try to find the value from your stats table. Okay, let's say you have this one. 8. So again, y less than 8. So it should be less than or equals to 7. Okay, does not include 8. So less than equals to 7. So use your stats table, n equals to 17. Your pi 0.3. So the same thing. Okay, now you have k is equals to 7. So 0.8954. Okay, dapat dia punya ni. On page 18 in your stats table, page 18. Okay, cuba completekan dulu. Try to complete this one. Okay, you try x less than equals to 5 and x greater than or equals to 3. Okay, so probability x less than or equals to 5. So it should be probability y. Okay, greater than 17 minus 5. So greater than or equals to 12. Okay. So again, 1 minus. So you want 12, 13 up to 17. So again, you will have 1 minus probability y less than or equals to 11. Okay, so the answer should be apa? Okay, so 0.0007. Okay, good. Okay, so it should be from your stats table 1 minus 0.993. Okay, so 0.0007. Okay, the next one. Okay, probability x greater than or equals to 3. Okay, so you will have probability y. Okay, follow the equality. So 17 minus 3, 14. So apa jawapan dia? Again, less than or equals to 14. Okay, if you refer to your stats table, the value is 1. Okay, 1, 1, 1. It's not 0 Hanin. 1. Okay, because okay, if you refer to your stats table, okay, we have the last value is 13. 13, the probability is 1.0, right? Okay, so 14, 15, 16, below that, all probability is 1. Okay, sebab dia punya maksimum tu apapun total probability dia still 1 lah. Okay, itu dia punya trick je lah. Tak ada apa-apa pun. Okay, again, x from 3 up to 8. From 3 up to 8. Okay, for this one, one by one lah kita buat. Okay, so that's mean, sorry. Okay, probability, okay, let's say 17 minus 3, so 14. Okay, so change your equality. You pun change. So 17 minus 8. So it should be berapa tu? 9 Okay, susun balik. So 9 less or equals to y less or equals to 14. Okay. So again, now you find from your stats table. Okay. So that's mean you want 10, 9, 10, 11, 12, 13, 14. So probability y less than or equals to 14 minus y less than or equals to 8. Okay. Sebab kita nak 9, 10, 11, 12, 13, 14. So 0 up to 14 minus 0 up to 8. So you get 9 up to 14. So y less than or equals to 14 is 1. So find from your stats table 8. So 0.9597. Okay. Then you get the answer. Okay. Okay, the last one. 2 less than x less than or equals to 9. Okay. So probability 2 less than x less than or equals to 9. So what we want is 3, 4, 5, 6, 7, 8, 9. So that's mean, sorry, itu x Kita tukar dulu. Okay. So we change the probability. So that's mean you have 17 minus 2. So 15 greater than y greater than or equals to 17 minus 9. Okay. So 8 y less than 15. Okay, so what you want is 8, 9, 10, 11, 12, 13, 14. Okay. So kita ada y less than or equals to 14. Okay. Ini dah ke bawah. Okay. Okay, you just find the probability. 8, 9, 10, 11, 12, 13, 14. Okay, so that's mean you will have probability y less than equals to 14. Okay, minus probability y less than or equals to 7. Okay, so again 1. So y less than equals to 7, you will have 0.8954. Okay, because you want 2 less than x less than equals to 9. So x less than equals to y less than 15. Okay, does not include 15. Okay, so again, you have probability y less than equals to 14 minus probability y less than equals to 7. Then you get the answer. Okay, So that is how you want to find the probability when we have case pi greater than 0.5. Okay, ini just exercise lah. Okay, macam mana kita nak gunakan stat stable tu. Okay, but again lah, the question should be in the long sentence. Okay. Okay, so let's say we refer to task 4.11. Okay, so again, you read the question. So identify what is your n, what is your pi. Okay. And if possible, what is your random variable x? Okay. Okay, again, this one you have 25 calls are placed to the A line. So the phone lines are occupied 70% of the time. Okay. If we write your x is binomial distribution. Okay. And 25, probability is 0.7. Okay, x represent number of lines that are occupied. Okay, number of lines. Sebab dia ataupun number of course lah number of course, sorry. Okay, number of course, okay. So sebab dia tanya kat sini, course Okay. Dia punya ni lah Okay, so again, what is the probability that the lines are occupied for exactly 10 calls? Okay, so exactly 10. So that's mean you want to solve probability x equals to 10. Okay, but again, your probability here is 0.7. So that's mean you need to change y, binomial 25 by 0.3. Okay, so exactly 10. So change to y, probability y, 25 minus 10, so 15. Okay, so you want to find exactly 15. Okay, so since given is your cumulative, so change probability y less than or equals to 15 minus probability y less than or equals to 14. Then you get exactly 15. Okay, in your stats table, you find n25, your pi is 0.3. Okay, and 25 on page 21. Okay, pi 0.3. Okay, you have 0.995 minus 0.9982. Okay, so itu exactly 10. Okay, tepat 10 lah So tukar, so you have probability y equals to 15. Again, given is your cumulative, so change. Okay, part 2. At least 15. You want to find at least 15. Okay, again, at least 15 are occupied. Okay, so we will have probability at least 15. Okay, so change to y. So 25 minus 15. So probability y less than equals to 10. So directly read from your stats table. And 25 by 0.3, so 0.9022. Okay, 0.90 Okay. Part 3, what is the expected number? What is the expected number of calls in which the lines are all occupied? What is your answer? So dia nak cari apa tu? Expected number, that's mean expected value. So use your property for your binomial. Okay, you already have the property expected value. So your EX is equals to n times pi. Okay, EX is equal to n times pi. Okay, this is the formula. So again, you want to find expected number of calls in which the lines are all occupied. So your N is 25. Okay, your pi is 0.7. Okay, that is your EX. Your expected number. Okay, itu maksudnya expected number. Sebab ini adalah expected value. Okay, so just use the formula. So if the question asks you what is the variance number of calls in which the lines are all occupied, so that's mean you have your sigma square and pi 1 minus pi. Okay. Okay, the last one. Last one, apa jawapan you all? What is the probability that more than 8 calls the line are not occupied? So is it X or is it Y? You should write X greater than 8 or Y greater than 8. Okay, Y, good. Okay, so it's direct, okay? Because your X represent number of lines or number of calls that are occupied. Your Y, your complement, so number of calls ataupun number of lines that are not occupied. So the last question asks you 8 calls the line are not occupied. So this is your Y. So probability Y greater than 8. Okay. So 1 minus probability Y less than or equals to 8. Okay, so just direct read from your sets table. N25 pi 0.3, so 1 minus 0.6769. Okay. Okay, so again, for binomial, check the question, check the probability given. Okay, so for certain question tu tak perlu tukar lagi lah sebab we already find this one, we already change your pi is 0.3, kita tukarkan pada 1 minus pi, which is, pi is 0.7 for your x, and for y, the complement is 0.3. So again, the question asks you more than 8 calls, the line are not occupied, so that is your y, so probability y greater than 8, so we just solve directly lah. 1 minus probability y less than or equals to 8. Okay. Okay, so we just proceed with the next question. Okay, that's 4.12. So the same thing, again 70%. Okay, pi is more than 0.5. So again, infected with a particular disease. Okay, you have 30 goat. Okay, first, write down. That's mean number of goats. Your X is number of goats infected with a disease. Okay, so X binomial entity pi 0.7. Again, change Y 0.3. Okay, what is the probability that 20 of the goat are infected with the disease? Okay, so that's mean you want to find ini infected, infected. Okay, so probability X equals to 20. Exactly X equals to 20. So we need to find probability Y 30 minus 20, which is 10. Okay, and then solve. Okay, exactly 10. So Y less than equals to 10 minus Y less than or equals to 9. So using the same thing, N equals to 30, 0.3. Okay, N equals to 30. Okay, find from your stats table. So the last value on page 24. Okay, so you have 0.7304 minus 0.588. Okay. Okay. The next one, less than 15 are infected. Less than 15. So less than 15, probability X less than 15. So that means if you change to Y, 30 minus 15, again 15. Okay. So greater than, so you will have 1 minus probability Y. So this one more than 15. So 16, 17, and so on. So Y less than or equals to 15. So the same thing, you read from your stats table, you should get 15. So 0 0.9936 eh. So 1 minus 0 0.9936. Okay, the last one. More than 8. Give me the last answer. More than 8. More than 8 goats are not infected with the disease. Nampak tak? Okay, more than 8. Berapa tu? Okay, more than 8 goats are not infected with the disease. So again, this one is your Y. So you want to find probability Y greater than 8. Okay. So 0.5685. Okay, so 1 minus probability Y less than or equals to 8. Okay, good. Okay. So itu konsep for binomial lah ya. Binomial where you have your case less than 0.5. You can read from your stats table and then more than 0.5. Okay. Dia biasanya soalan dia taklah. It's not too complicated. Okay. As long as you understand how to read the stats table. Okay. And then just kalau let's say if you have careless mistake je lah. Careless mistake mungkin different row ataupun different column you read from your stats table. That is biasanya memang student selalu buat macam tu. And then mungkin tersalah baca sikit dia punya probability tu lah yang kita tanya lain, yang dia jawab kat sini lain. Okay. Kadang-kadang kita bagi probability of success, kita tanya yang failure. Macam tu lah. So just check the question carefully. Macam mana nak tahu dia X or Y? So it depends. Okay. Sebab kalau kat sini, biasanya kalau kamu tak nak confuse, okay, better you define what is your random variable X. Okay. So random variable X is given when your pi in this case, let's say 0.7. 0.7 tu adalah probability of success. Success kita dalam case ni adalah probability that the code is infected with a disease. So that's mean your X here is number, okay, goods that are infected, okay, with disease lah. Okay, disease. Okay. That is your X. So Y, dia punya complement dia, again lah number of goods tapi are not infected with the disease. Okay, itu dia punya complement dia. So when you use X ni, pi kita 0.7. Okay, tapi 0.7 ni is not in your stats table. So you have to modify or change your question, how you set up the question. So we change to Y. Y and still sama. Yang berubah je dia punya pi ni, 1 minus 0.7, which is 0.3. So 0.3 is the probability that are not infected. Okay. So the question, the first one, 20 of the good are infected with the disease. So still your X. Okay, X equals to 20. Okay, tapi kita tukar pada Y. Sebab kita nak baca table. Tak ada. Kalau tidak, kalau ini, boleh guna manual, not manually, using your probability mass function, boleh. Masukkan NCX, pi to the power X, 1 minus pi to the power N minus X, boleh. Dapatkanlah probability X equals to 20 without change to Y. Okay. Tapi if you want to use your stats table, you need to change. Because again lah, pi 0.7 is not given. So we use 0.3, so change X to Y. So that's why kita semua tukar kat sini lah. So ini pun sama, less than 15 are infected juga. So start dengan X dulu. Kita tukar pada Y. So again, because dia 30, so 30 minus 15, 15. So tukarlah 1 minus 40 Y less than equals to 15. You mean the details, is it the random variable you want to define. Um, unless the question stated apa ya? Write X. What is your X? Define X. So you have to define lah. Maksudnya X is number of something. Apa dia punya tu? Atau number of defective item. That is your X. Y number is non-defective item. Okay, maksudnya kalau kita tulis lah. Tapi normally yang in your exam or test, what I need is this one. Ini ni. X distributed sebagai apa? Y distributed sebagai apa? Okay. Dia punya random variable ni, kalau let's say if you don't want to get confused. Okay. So just write. What is your X? What is your Y?